Dependency injection is a software design pattern that implements inversion of control and allows a program design to follow the dependency inversion principle. The term was coined by Martin Fowler. An injection is the passing of a dependency to a dependent object. The service is made part of the client state. Passing the service to the client, rather than allowing a client to build or find the service, is the fundamental requirement of the pattern. Overview: Dependency injection is a software design pattern in which one or more dependencies are injected, or passed by reference, into a dependent object and are made part of the client state. The pattern separates the creation of a client's dependencies from its own behavior, which allows program designs to be loosely coupled and to follow the dependency inversion and single responsibility principles. It directly contrasts the service locator pattern, which allows clients to know about the system they use to find dependencies. Dependency injection involves four elements: the implementation of a service object, the client object depending on the service, the interface the client uses to communicate with the service, and the injector object, which is responsible for injecting the service into the client. The injector object may also be referred to as an assembler, provider, container, factory, or spring. Implementation of dependency injection is often identical to that of the strategy pattern, but while the strategy pattern is intended for dependencies to be interchangeable throughout an object's lifetime, in dependency injection only a single instance of a dependency is used. Application frameworks such as Spring, GEIS, GlassFS K2, and Microsoft Managed Extensibility frameworks support dependency injection. Advantages: because dependency injection doesn't require any change in code behavior, it can be applied to legacy code as a refactoring. The result is more independent clients that are easier to unit test in isolation using stubs or mock objects that simulate other objects not under test. This ease of testing is often the first benefit noticed when using dependency injection. Dependency injection allows a client to remove all knowledge of a concrete implementation that it needs to use. This helps isolate the client from the impact of design changes and defects. It promotes reusability, testability and maintainability. Dependency injection can be used to externalize a system's configuration details into configuration files, allowing the system to be reconfigured without recompilation. Separate configurations can be written for different situations that require different implementations of components. This includes, but is not limited to, testing. Reduction of boilerplate code in the application objects, since all work to initialize or set up dependencies is handled by a provider component. Dependency injection allows concurrent or independent development. Two developers can independently develop classes that use each other, while only needing to know the interface the classes will communicate through. Plugins are often developed by third-party shops that never even talk to the developers who created the product that uses the plugins. Disadvantages: dependency injection can make code difficult to trace because it separates behavior from construction. This means developers must refer to more files to follow how a system performs. Dependency injection typically requires more lines of code to accomplish the same behavior legacy code would. Dependency injection diminishes encapsulation by requiring users of a system to know how it works and not merely what it does. Dependency injection increases coupling by requiring the user of a subsystem to provide for the needs of that subsystem. Examples: hard-coded example, in the following Java example, the client contains a service member variable that is initialized by the client constructor. The client controls which implementation of service is used and controls its construction. In this situation, the client is said to have a hard-coded dependency on service example. Dependency injection is an alternative method to initialize the member variable. Three types of dependency injection. Martin Fowler identifies three ways in which an object can receive a reference to an external module. Constructor injection: the dependencies are provided through a class constructor. Setter injection: the client exposes a setter method that the injector uses to inject the dependency. Interface injection: the dependency provides an injector method that will inject the dependency into any client passed to it. Clients must implement an interface that exposes a setter method that accepts the dependency. Other types. It is possible for frameworks to have other types of injection beyond those presented above. Some attempts at inversion of control do not provide full removal of dependency but instead simply substitute one form of dependency for another. As a rule of thumb, if a programmer can look at nothing but the client code and tell what framework is being used, the client has a hard-coded dependency on the framework. Constructor injection requires the client to provide a parameter in a constructor for all dependencies to be injected this way. Setter injection requires the client to provide a setter method for each dependency. Interface injection, this is simply the client publishing a role interface to the setter methods of the client's dependencies. It can be used to establish how the injector should talk to the client when injecting dependencies. Constructor injection comparison, preferred when all dependencies can be constructed first because it can be used to ensure the client object is always in a valid state, as opposed to existing when some of its dependency references are null. However, on its own, it lacks the flexibility to have its dependencies changed later. Setter injection comparison requires the client provide a setter method for each dependency. This gives the freedom to manipulate the state of the dependency references at any time. This offers flexibility, but if there is more than one dependency to be injected, it is difficult for the client to ensure that all dependencies are injected before the client could be provided for use. Since these injections happen independently, there is no way to tell when the injector is finished wiring the client. A dependency can be left null simply by the injector failing to call its setter. This forces the check that injection was completed from when the client is assembled to whenever it is used. Interface injection comparison. The advantage of interface injection is that dependencies can be completely ignorant of their clients yet can still receive a reference to a new client and, using it, send a reference to self back to the client. In this way the dependencies become injectors. The key is that the injecting method is provided through an interface. An assembler is still needed to introduce the client and its dependencies. The assembler would take a reference to the client, cast it to the setter interface that sets that dependency, and pass it to the dependency object, which would turn around and pass a reference to self back to the client. For interface injection to have value, the dependency must do something in addition to simply passing back a reference to itself. This could be acting as a factory or subassembler to resolve other dependencies, thus abstracting some details from the main assembler. It could be reference counting so the dependency knows how many clients are using it. If the dependency maintains a collection of clients, it could later inject them all with a different instance of itself. Assembling examples. Assembling in main by hand is only one way of implementing dependency injection. Frameworks like Spring allow assembly details to be externalized in configuration files. Spring will construct these objects and wire them together before returning a reference to the client. In this example, client and service have not had to undergo any changes to be provided by Spring. This shows how Spring can service clients that are completely ignorant of its existence. This could not be said if Spring's proprietary add-order-wired annotation were added to the classes. By keeping Spring-specific annotations and calls from spreading out among many classes, the system stays only loosely dependent on Spring. This is important if the system intends to outlive Spring. Assembly comparison. The different injector implementations are not that different as far as dependency injection is concerned. What makes all the differences where they are allowed to be used? Move calls to a factory or a service locator out of the client and into main, and it suddenly makes a fairly good dependency injection container. By moving all knowledge of the injector out, a clean client, free of knowledge of the outside world, is left behind. However, any object that uses other objects can be considered a client. The object that contains main is no exception. This main object is not using dependency injection. It's actually using the service locator pattern. This can't be avoided because the choice of service implementations must be made somewhere. Externalizing the dependencies into configuration files doesn't change this fact. What makes this reality part of a good design is that the service locator is not spread throughout the code base. It's confined to one place per application. This leaves the rest of the code base free to use dependency injection to make clean clients. See also, architecture description language, factory pattern, inversion of control, plugin, strategy pattern, references. External links, A Beginner's Guide to Dependency Injection and Testable Objects, Designing Loosely Coupled and Testable Objects, Jeremy Riescotten. Dr. Dobbs Journal, May 2006. Design Patterns, Dependency Injection, MSDN Magazine, September 2005, Martin Fowler's original article that introduced the term dependency injection, PVAA, plugin, The Rich Engineering Heritage Behind Dependency Injection, Andrew McVeigh, A Detailed History of Dependency Injection. What is dependency injection? An alternative explanation, Jacob Jenkov, Writing More Testable Code with Dependency Injection, Developer.com, October 2006, Managed Extensibility Framework Overview, MSDN, Old-Fashioned Description of the Dependency Mechanism by Hunt 1998, Refactor Your Way to a Dependency Injection Container,